Well, I got this meter back together without too much trouble. It was definitely difficult to get apart and difficult to get back together, but I did it without any issue, didn't ruin anything, so that's a good thing. Started doing a little bit of testing with it, and all of a sudden it just plain completely died. No intermittent, just died a total death. So I ripped the thing back apart, and come to find out that this switch here was messed up. They've got kind of like a little metal leaf. There's two of them here that go across bridge across two circuit tracks. Well, picture the one behind it. It was kind of up like that, and it was just barely making contact. Sometimes it would, sometimes it wouldn't. So I turned that switch off, and then I took one of my little dental pick things and yanked that thing down about as far as I could several times, so where it could make good contact there. And that seemed to have taken care of that problem. I've been using it quite a bit now, and seemed to work pretty good. Like I said, even though this is an analog meter, it's actually a fairly high quality one, built in West Germany in the mid-1980s. And generally you don't get anything but high quality from Germany, and this is no exception. This has one nice thing about this particular analog meter. It's got a 10 mega ohm input impedance, just like your good digital multimeters will have, so it's not going to load the circuit down. And it's actually, for an analog meter, it's reasonably accurate. I really wish that I could find a English manual for it. I did find a German manual online, and well, I can't speak German even though I am of German descent, so I really can't get anything out of it. But there's 3 pots internally there where I could probably adjust the accuracy of this and get it right on. But without knowing what each one of those pots do or what sequence to use, I really don't want to mess up the calibration as it is. I've got my little DMM check here, so I'll demonstrate how the accuracy of this thing. Okay, that's a 5-volt input right there. As you can see, probably with the meter you're going to have some parallax. I don't know exactly where. I'm trying to look in the viewfinder here, but that's pretty much right on 5 volts though. I'm on the 10 volt scale, so you're looking at the top scale there. So the 50 is actually 5 volts. Now if I move up to the 30 volt scale, it's right on 5 right there as well. That's for the DC voltage. I'll need to get some more of these. They make a version of this with several voltages. You can step up to, I don't know, maybe like 10 volts or something. I can't remember. I need to get a couple more of these, and they also make them in AC as well. But turn this over to the DC current. And for the lower current ranges, you use the regular input, and then for the 10 amp, then you move the leads up to this other input. But let's see, this is a 1 milliamp. Let's see, hopefully I don't bounce this thing off the end. Okay, good. And using the top scale, it's right on I'm on the 10 milliohm range, so that's showing pretty much exactly 1 milliohm. So I'll shut this off to save the battery. We've got our little precision resistors on here. It's been a long time since I've used an analog meter. You got to kind of, for each time you change ranges, sometimes you have to tweak the zero slightly. Let's see here. This is the 1 kilo ohm resistor, and we're on the times 10 scale, and as you can see, it's pretty much right on 100. I'll move up to the times 100 scale, and it shows slightly high on the 10, but it's still pretty close. Now we'll go to the 10K resistor. Again, pretty much right on the 100 on the times 100 scale. Go to the times 1K scale, and again slightly high on the 10, slightly over 10. And now to the 100K scale, and we're pretty much right at the 100 on there. I'm on the times 1K scale. Go to the times 10 scale, and slightly high in the 10. So as you can see, without having any information on how to tweak this thing in, it's already quite accurate, and it's a very nice unit. And I really like this style of meter. Clear back in the early 1980s, the first multimeter that I ever got was a Microna, which is Radio Shack house brand at that time, clamshell type meter like this. I really like this style of meter because for on the bench, because you can sit this thing wherever you want and get whatever angle you want, and pretty much set it way off in a corner somewhere out of the way and still be able to read it pretty well. With a standard stand-up multimeter like one of these, you're kind of limited on where you could put it. It's always wanting to fall over. I just like this low, wide style like this. So I've got this analog. There are times when an analog meter comes in handy compared to a digital meter if you're trying to, if you're looking for, say like, for example, if you're testing like a cable and you think you have a discontinuity in that cable, you can hook these leads up and you can twist the thing around and you'll see the meter bouncing up and down a lot easier. It'll respond a lot quicker than say a digital multimeter would, even though the flukes have their little bar graph that's supposed to represent a analog meter. I still like the swing of an actual analog, true analog meter. But they made a digital version of this particular meter. It looks identical, other than the fact that it has a 3.5 digit digital display. That's my next thing. I'm going to start searching on eBay. I got to search out on eBay right now, and there's actually one on eBay, but the seller wants a little bit more than I really want to pay for it. So it's just like everything else. I'll be patient. One will come up that's a good price. I've had to search out on this one here for 6 months, and several of them came up for $70, $80. I'm not paying that much for a 30-year-old meter, and this one came up for a pretty reasonable price, so I did finally buy it. But definitely nice meter, nice compact. Fold that thing up and throw it in your glove compartment or into a drawer or whatever, and off you go.